We're going to be going over exponential growth. So we've been given a problem here. It says that there are 5,000 yeast cells in a culture. The number of cells grows by 25% every single day. And the question asks us, in 7 days, how many cells will be in the culture? Okay. So because we have a percentage increase, we are using an exponential equation here. We have y is equal to a b to the power of x. Now, there's a couple of things we need to talk about. First of all, a is our initial value, if you guys remember from yesterday. All right? Initial value, which in this case, what is our initial value? How many cells are there? That's right, 5,000. So in this case, our a is 5,000. Now, b is a growth rate. And we talked about this. We said if b was greater than 1, it's growth. And if b is between 1 and 0, it's decay. Now, in this question, are we growing or decaying? It says we're growing by 25% every year. So what would be a growth rate? I guess, what will our exponent need to be? What will our growth rate be in this case? Because it's growing by 25% every year, okay? What is our 100%? How can we represent that as a number? Our b is going to have to be what value? What we're going to have to do is split our b. So, our a is 5,000, and b has to be turned into, because it's growing, it has to be 1 plus whatever the percentage increase is to the power of x. Okay, so we have to recreate the growth rate here. So what was our percentage growth rate? It was 25. Okay, but we can't just put it as a value of 25. We have to turn it into a decimal. What is 25 as a decimal? 0.25. So when we go to recreate this formula, it is y is equal to the initial value, which is 5,000, and then 1 plus that growth rate, which is 0.25.
So what?
Because 1 is, think of it like 100%, right? 1, when we write as a percentage, represents 100%. And if it's growing, it must increase by at least 100% every year. It has to keep the same initial value. So we have to be greater than 1 to grow.
Oh.
That's okay. It's not a big deal. So we then have to add that value. So we're going to end up with a number that is going to be greater than 1, which is perfect because we said this was a growing amount. So 1 plus 0.25 will give us 1.25. Sorry, I don't know why I wrote to the power of 2. That should be an x. Now our x, because it's 25%, how often was it increasing by 25%? Every day. Okay? And the question asks us, in 7 days, how many cells will be in the culture? So x is representing the number of days. Okay? Or the number of increases by 25%. So because we're going in a course of 7 days, we have to turn x into the value of 7. Y is equal to 5,000 times 1.25 to the power of 7. First we do the exponent, 1.25 to the power of 7. Let's get a calculator out here. So 1.25 to the power of 7. Okay, and then I need to multiply that by 5,000. 23,841. Okay, 23,841. Just going to erase the second step. I didn't write it in. I did it all in the calculator. So after 7 days, this culture increases to a very large number, 23,000 compared to the 5 it started at. Okay, which goes to show you that exponential can increase and grow by very large amounts very